8A, we are doing the water cycle. Our part is the oceans. The oceans are the main water suppliers to the water cycle.
The oceans cover around 70% of the Earth's surface and contain roughly 97% of the Earth's water supply.
Without the oceans, the water cycle would be non-existent. There would not be enough water on the Earth's surface to support the cycle.
The ocean is constantly changing. The high tides and low tides, caps melting and ice caps forming.
The water in the ocean is about 3.5% salt.
As water flows in the rivers, it picks up small amounts of mineral salt from the rocks and soil on the riverbed. The slightly salty water flows into the oceans and seas.
The water in the ocean only leaves by evaporating, but the salt remains in the ocean. So the remaining water gets saltier and saltier as time passes, with the new water coming in, which is salty. The water cycle. So for us, the water cycle kind of starts in the ocean, even though it doesn't have a start and an end, because it goes up and the sun makes it condense into clouds,
which turns into vapor, steam, and then goes up and turns into clouds. Gets cold, turns into clouds,
and then it precipitates. So clouds form rain, snow, hail, any kind of form of water falling from the sky. That goes into rivers and streams.
Or either straight to the ocean.
Yeah,
just goes
either straight to the ocean, or goes into groundwater, which goes straight back into the ocean.
Excellent, knocked it out of the park. Brilliant. All right, number 2, let's go. Number 2, go lads. If you have a video show or a PowerPoint show, just feel free to come closer to the camera and we can play it on there as well. All right, good work, Tess and Sabrina. Smash that for a home run. It's going to be hard to. Are we ready, lads? Let's go.
Alright, we're talking about evaporation. Evaporation is one of the main processes in the water cycle. What is evaporation? Evaporation is when water on the land or ocean is taken into the air as gas or vapor. The water cycle is the cycle that produces and recycles water over and over. Evaporation would be impossible without the sun, and the sun... I'm apparently not meant to read that bit.
Yeah. And we had a little video, and it would have been longer, but our video is...
We just have to record the audio.
Okay, just want to show the start anyway?
No.
All right, emails can read down and put it on the blog. Excellent. All right, brilliant. Thank you very much. Number 3.
All right. I didn't phrase that right.
Yep.
Slide presentation.
All right, guys, please. Please quiet down. This is it, guys. All right, here we go. Thank you, lads. Number 3.
Put it close to the camera. No. Alright, so...
Guys.
So here's the water vapor in the air.
So what are you doing, sorry?
Condensation.
All right, thank you.
And then it gets they start sticking together, and then they become more visible, and then they eventually turn into a cloud. And that's pretty much condensation.
Excellent, thank you.
Condensation happens when there is a lot of water vapor in the air and the water molecules cling together. When enough molecules are together, they form clouds, and first it's the fluffy white clouds that you see. They're actually quite high up, and that's because they're not very dense, so they stay up high, and there aren't many water molecules in them. And then after that, they become dark black clouds, and they're pretty low because they're dense and they're heavier, so they drop down. It's because when there is so much water vapor in the cloud, it becomes too dense and it falls back down in liquid form, or like rain or hail or snow, and that's precipitation. And the whole water cycle is the vapor coming from the heat of the sun onto the oceans and lakes and rivers, and that heats up the water, and then the vapors come up, and then all the vapor in the air clings together and condenses into clouds, and then the clouds get dense enough so that it rains or snows or hails, and then that flows back into rivers or lakes or oceans and it starts again.
Excellent. Great, thank you lads. All right, very detailed. Like we filmed that because then we can go back and read it. All right, what are we up to? Number 4. All right, lads. Thank you, Nucky. Do you have a presentation or how you presenting it or just reading? Let's go, lads. Everyone quiet, please. Remember you need to be paying attention to these guys. They will be explaining the individual parts of the cycle, which is important, which is interesting. Okay, you will need to know these things. Again, we have the video, you can watch it anytime. Yay, technology. All right, let's go.
We're doing storage of water in the atmosphere. Atmosphere. The atmosphere in the water cycle stores and moves the water through the air and around the earth. The atmosphere plays a big role in the water cycle by storing water and keeps the water flowing into the ocean so that the water cycle can continue. The way the atmosphere stores water is that when the streams and rivers reach lakes and dams, the water is stored there and then evaporates into the atmosphere.
Brilliant.
And now the water cycle.
Okay, so we're on the next one. Here we go.
The water cycle is a series of events that store and move water all around the Earth. Now, the water cycle starts at the ocean, evaporation and condensation lift the fresh water up because salt is too heavy for it. And onto the clouds, and the clouds travel to mountains and valleys and all that. And then it rains, and the water travels down streams and rivers, and then when it reaches, and underground water as well, and when it reaches the ocean, the water cycle starts again.
Excellent. Brilliant summary. Brilliant. All right, we go number 5, which is the hard one to say. Yes, excellent. All right, we'll do it. Sorry? Oh, you have a play. All right, go guys, please pay attention. We have a play. I'm excited right now.
So, the word we're doing is evapotranspiration.
Say that again slowly, because it's awesome word.
Evapotranspiration.
Brilliant.
Right. Hello. My name is the groundwater table. And this is my tree. My very special tree has her roots in me. It was my turn to do the water cycle today with my buddy, evaporation. So shall we go? I'm feeling thirsty today, so I'm going to suck this groundwater up. Okay. Okay, now that I'm feeling fresh and revitalized, I'm going to send my water out into the air. I have to go now.
Wow. Whoa. Sorry.
Okay, so I am the groundwater, and I'm going to evaporate and meet my friend Transpiration up in the air. Okay, so hello. I'm evaporation. I'm transpiration, and together we're evaporation. We're evaporation. Evapotranspiration. Let's go see what else we can find up in the clouds. Okay, let's go. We're in the clouds now because we just evaporated. In the clouds, well, this is the water cycle.
Thank you.
Okay. In the clouds, there's condensation. That's when the rain, well, you get heavy, and when the clouds are too weak to hold you anymore, there's precipitation. When rain, snow, and hail fall onto the ground again. We go down the surface runoff, and we go into lakes, rivers, and oceans where we all started. And it all happens over and over again. And now we're water.
Before you go, we've decided that the Oscar for best, what's the word again?
Evaporation, transpiration.
Documentary goes to you. There you go. Hold on to that. It'll be worth a fortune. All right, thank you very much. Here we go. That was interesting and informative. All right. Number 6, please. Guys, remember we need to get this done before we leave. We're on number 6. Here we go. Quiet, please, guys.
Okay. We don't say everything. What didn't fix that up? Anyway, I told you to fix it up.
Guys, are you ready? Everyone, thanks, lads.
Hello, as you all know, I am Jack O'Keefe, and this is my co-weather reporter, Bo Pemberton. Today we are here to talk to you about something very interesting, is sublimation and desublimation. Sublimation is the conversion of ice or snow into vapour in the air without melting. Desublimation is the opposite. Desublimation is vapour freezing as in frost or snowflakes. Sublimation is hard to see, but there is a way that you can see it, is to hang a wet towel or cloth out at 0 degrees and watch as ice transforms into evaporation without liquidizing.
Thanks, Jack. Alright, the water cycle process. The water cycle is a process of rain basically in a recurring cycle. The sun evaporates the water in the ponds, dams and oceans, etc. The evaporations turn into clouds and the process is called condensation. Then the clouds blow into other places by the wind and then it precipitates back into the ponds, oceans and dams. Thanks for listening.
And this has been 10 News. Now, on to The Simpsons.
Brilliant, thank you, product placement and everything. All right, good work, lads. Number 7. Thanks, ladies.
Today we're doing words.
Stick up.
Okay, we're doing precipitation, and precipitation is basically the water that falls from the clouds.
So another word that could be is
Rain. The main forms of precipitation include drizzle, rain, sleet, snow and hail. Precipitation occurs when the clouds become heavy because they are filled with too much water that has been evaporated from oceans and lakes. So the water that falls from the clouds is rain.
Precipitation is important to the water cycle because it is the actual rain or water that evaporation, oceans, lakes and clouds work together to make. Without precipitation, the steps after it on the water cycle become non-existent. The water cycle starts with the ocean. Water gets evaporated from the ocean and is sucked up to the sky where the water forms clouds. When the clouds have sucked up too much water, they release that water as rain, hail, snow or drizzle. The rain that falls from the clouds ends up on land or back in the ocean. When it lands on the land, it flows back to the ocean through streams and rivers.
brilliant. All right, excellent work. Can I just have a squeeze of that? Let's just do some action. There we go. Lovely poster. All right, brilliant. Okay, thank you very much. Let's go. What are we up to? Number 8. Number 8, please. Good work, ladies. Perfect. Alright, here we go.
Can we plug it in? Yeah, can we plug it in?
No,
Okay, we'll just read them.
just read it out. It just takes too long. That's all.
Alright, okay. So we did, ice, snow, and glaciers.
What is a glacier? A glacier is a large body of ice or frozen water. Over sometimes centuries, the frozen ice will melt or often crack, and a large amount of the ice will fall into the water. Glaciers only form on land and are often found in between mountains. Glacial ice is the largest reservoir of fresh water on Earth, supporting up to a third of the world's population.
Whoa, that's a good one.
How snow forms. The process of snow begins in the atmosphere when water condenses into tiny droplets. As more and more condensation enters the clouds, the tiny water droplet grows bigger and cold air freezes the water, turning it into ice crystals or snowflakes.
which then fall into the ground. Which then falls to the ground. Each snowflake has a unique shape, which is developed when it is freezing and there is a lot of water vapor in the air. It develops 6 evenly spaced processes.
What is ice? Ice is water that's frozen solid. It can appear to the eye as transparent or an opaque blue or white colour. Ice appears naturally in forms of snowflakes, hail, icicles, ice spikes, candles, glaciers, or frost.
Okay, what is water vapor? Water vapor is water vapor is water in its gaseous state instead of a liquid or solid.
Are you laughing because you said gaseous?
I'm just laughing.
Alright, okay. Alright, keep it together.
Okay.
Hard stretch.
Solid ice. Water vapor is total.
Alright, ladies, stop.
Okay,
Stop.
Sorry.
Alright, here we go. Great.
Okay, water vapor is totally invisible. Clouds, fog, and mist are all liquid water, not water vapor. However, these things do need water vapor to form.
Why is snow and ice important to our climate? Snow and ice is important to our environment. With less of these, it can decrease global warming because glaciers and ice sheets will melt in Antarctica, causing sea levels to rise.
Excellent. Great. Go give us a round. Check the presentation. What do we have? Lovely. There it is. There's the presentation there. The slides. Lovely. Brilliant. Thank you very much. Okay. Let's go. 9. Alright guys, as we're running out of time, what we might do, ladies, what we're going to do, as we're running out of time, we'll just get you to explain your section and why it's important. Okay, you don't need to worry about explaining the water cycle again. We'll end that with Mr. Sam and do it for us. Alright, here we go.
Snowmelt runoff is when melted snow runs down mountains into lakes, rivers, and oceans. If we didn't have snowmelts, we would have a lot less lakes and rivers because the snow would stay frozen.
Perfect, easy, excellent, wonderful, brilliant, thank you very much. Let's go. That was a lot of description. Okay, here we go. No, I think my words. Alright, number 10. Yeah. So that's what I mean, guys. You can do this nice and simply. You can summarize it, you can round it up in your own words. That's all I want, your own words. Alright.
Jesse.
Let's go, Jess. Ryan.
Move over, can't see you. Yeah.
There we go. Alright, excellent.
Well, we're doing surface runoff. Yeah. Okay, surface runoff is when water from the rain falls to the ground on a hill and forms a group of droplets to make a rivulet. Okay.
What was that, sorry, Ryan?
Rivulet.
That's a lovely word, I like
I know.
that.
Fantastic. That then flows to a lower down part of the mountain and like a big pool of water. Yes.
A good example is when water flows down from your driveway into the curb down to the gutter. So yeah. Surface runoff is really important because if we didn't have surface runoff, we wouldn't have waterfalls, a good way to exercise. But and if we didn't have surface runoff and physics wasn't working, we wouldn't have rivers and oceans flowing everywhere because the surface runoff water that flows down, all that would just stay on the mountains. So anyway, with the water cycle thing, water from the oceans and rivers, all that heat up, rise to the sky. This is evaporation. It then cools down and clusters together to make clouds. This is condensation. And then the clouds get so heavy that water droplets fall down. This is rain. So yeah.
Good one, clouds when they get heavy, the water droplets. Excellent. Good work, Ronan. Brilliant. And Jeff.
I was doing stream flow. Stream flow is caused by snowmelt, direct rain into a water channel and groundwater runoff. Some people use stream flow to describe how much water is running through a water channel, but it is basically just another word for rivers, streams, and creeks. Rivers flow down hills and into the ocean unless diverted, sometimes by a closed lake and more often by human purposes. Rivers flowing back into the ocean is important because it means that there is a consistent large body of water for the sun to evaporate to continue the water cycle.
Excellent, good work, brilliant, wonderful. Alright, here we go, we're up to number 12. We're nearly at the end, I'm excited. Quite an important one, lads. What? Alright everyone, we're on the home stretch here. The water cycle is coming to an end. Lads, this is quite a tricky one to explain.
But it never comes to the end.
Go, go. Go, lads.
Infiltration happens when water soaks into the soil from the ground level. It moves underground and moves between the soil and rocks. Some of the water will be soaked up by roots to help plants grow. The plants leaf eventually release the water into the air through the plant's pores. So, some of the water keeps moving down into the soil to a level that is filled with water, called groundwater. The very top of this layer filled with groundwater is called the water table.
Excellent. Do you want to repeat that last line, Jordan? That was quite important. The water that's under the ground?
The water that is under the ground is called groundwater. The very top of this layer filled with the groundwater is called the water table.
Water table. Excellent. We'll talk about that one a little bit later. Excellent work, lads. Here we go. We're nearly there. We are up to 13. Lads, what are we doing? Yeah, come on. 2 more minutes to get out of here. Let's do it.
We're doing springs. What is a spring? A spring is a capture of fresh water. Springs are usually found at the bottom of a hill or in a valley. There is usually a stream flowing into the spring and stream flows coming out of the spring. The stream flows coming out of the springs head towards rivers or big lakes. At the bottom of most springs, there are cracks and holes into the ground. This creates more springs flowing underground.
All of the water in springs come from participation in springs and the evaporation of the groundwater.
Excellent, thank you, lads. Brilliant. All right, here we go. Home stretch. What are we up to? 14. Then, lads, you sum it up and we go. Alright, here we go. Quiet up, this guys. Come on, we're nearly there. Be like that.
Okay. We're doing freshwater. Freshwater is essential to all life on Earth. Freshwater includes streams, ponds, lakes, reservoirs, canals, and freshwater wetlands. The source of almost all freshwater is precipitation from the atmosphere in the form of mist, rain, and snow. The amount of freshwater in lakes, rivers, etc. are always changing. The amount of water increases because of precipitation and it decreases because of evaporation.
Excellent, thank you, brilliant. And sum it up. The claps seem to have died down, but they were amazing. Alright, here we go. 15 and 16. PowerPoint presentation.
Oh yes, Sam, I was talking about the water cycle, so you can do all that.
Oh no, look.
Alright, how do we sum it up with this, shall we?
Sam, you can just say all that, and I'll just do the water cycle at the end.
Okay.
That'll be easy.
Oh yes, we did our PowerPoint.
Like I said, it's not the best.
You don't really need to do it. No. We don't really need it.
Alright, let's go then. Go! Ladies,
Don't worry about how bad.
gentlemen,
Groundwater flow is water that runs underground.
Sorry guys, I cannot hear them. Thank you. Go down.
Groundwater flow is just water that runs underground, and it gets there by seeping into the soil on the surface. Some of it evaporates, but most of it either gets sucked by the roots of the plants, or they go down and form aquifers. And aquifers are basically groundwater storage, is groundwater storage. Groundwater storage is just when groundwater, there's two types of groundwater flow and groundwater storage. And so groundwater flow runs off into other streams or oceans, whereas groundwater storage just sort of sits there and gets trapped there by rocks or ice or soil or hard soil.
Alright, because we're last, we have to go through the water cycle again. So the water cycle is pretty much the water gets evaporated from the oceans and goes up to the air, condenses, makes clouds, and then the clouds get really heavy and it rains. Normally rains up on mountains, and then all that runs down and back into the ocean and starts the cycle all over again.
Excellent, thank you very much, lads. Let me just quickly show you a presentation. No one leaves us yet. Boom, boom. All right.